Hello. Now we'll start section 1.3, which is about observational studies and sampling strategies. So, topics to take note on for while you're reading this section and while you're listening to this video are the words population, sample, and census. Also, it'd be good for you to know what exploratory analysis is, inference, and the word representative. Also types of bias and sampling techniques. And finally, can't really see it, let me move myself. Types of observational studies. Okay. So I'd like to start off with examples. So here is a thing about finding your ideal running form. So the question was, can people become better, more efficient runners on their own merely by running? And the population of interest was all people, but the sample was a group of adult women who recently joined a running group. And so the population to which results can be generalized would be adult women if, let me move myself here, adult women if the data are randomly sampled. It's a big if. Okay. And then also, like, why this guy's hat? What's going on there? Who knows? All right. Then anecdotal evidence and early smoking research. So what did we do in the last slide? We talked about population of interest. Okay. Population of interest is like what you want to generalize the study to. Sample is the actual people or whatever that you talk to. And then the population to which the results can be generalized is what is the sample representative of? All right, here's another example of talking about anecdotal evidence in early smoking research. So anti-smoking research kind of started in the 30s and 40s when cigarette smoking became increasingly popular. Some people suffered different things, such as lung cancer. Other people were totally fine. And anti-smoking research was faced with resistance based on anecdotal evidence, such as, my uncle smokes 3 packs a day and he's perfectly good health. And it's concluded that smoking is a complex human behavior and it's difficult to study. It's confounded by human variability. So in time, researchers were able to examine larger samples of cases and show trends that smoking does hurt people's health on average. Even though individuals might not be hurt by smoking, on average it does. So for instance, I think they showed that you're 12 times more likely to get lung cancer if you smoke. That doesn't mean you will get lung cancer if you smoke. Lots of people will not get lung cancer if they smoke. But each person is increasing their chance of lung cancer times 12. Okay, let me move back down in the corner. All right, another vocab word, census. So wouldn't it be better to just include everyone in the sample? Just sample the whole thing, sample everyone. That's called a census. And there are problems. It's often difficult to do that. Sometimes it's possible, but oftentimes it's difficult. So if you want to know something about, say, all Americans, all people, you can't, it's really hard to do that. And populations rarely stand still. And so taking a census can be really complex sometimes. Although we do take a census in America every 10 years. So the most recent census was last year. Here's a NPR story from back, not 2020, but the census before that, 2010, talking about how sometimes people can be less likely to answer. Certain populations could be less likely to answer a census. Okay, exploratory analysis to inference. Okay, so exploratory analysis is looking at like what you've got and kind of exploring the data. Inference is when you say that about the population. So sampling is something that's very natural. So think about if you're cooking and say you're making a soup or something like that, then you taste a small part of it to make sure that, say, you have enough salt in there, and you want to taste the soup is exploratory analysis. Okay, and then if you generalize your taste to the whole soup, that's called inference. Okay, so then hopefully your taste test is representative of the soup. So if you didn't stir it very much, maybe you're getting something off the top that's not quite representative of the whole soup. That's called being biased. It's a biased sample. But if you stir it really well and you sample it, then your sample is representative, and you can infer to the whole population what you figured out with the sample. All right, sampling bias. Now, bias is something that's often used in our everyday language, but it means something very precise in statistics. So let me go back. So, in our everyday language, like, oh, I don't like that person's opinion. They're super biased. Bias in statistics means it regards a sample in a population. And if the sample is not representative of the population, then it is biased. That is the only definition, the only way we use the word bias in statistics. Okay, now there are very common ways to be biased. One of them is a non-response. Okay, so if you give out a survey and not many people fill it out. So for instance, this is always a problem with the end of course, the course evaluations at the end of every course. This is why we always encourage students to do these. We don't want a non-response bias. We want everyone to do one, or at least we want as many as possible to do it. Volunteer response. So this is where oftentimes something online, where there's an online sample and online survey, and not that many people do it, like only people who are volunteering to do it. So like, have you seen a picture like this? Quick vote. This sort of thing. Okay, so convenient sample would be individuals who are easily accessible, like to be included in the sample. So for instance, if you want to know something, and so you send out a survey to all your friends, that's a convenient sample. You're not being random. You need to be, to be representative of the population, you need to find a way to do it randomly, not just like the people you know. All right, let's talk about a historically bad sample. So in 1936, there was a presidential election between Landon and Franklin Delano Roosevelt, otherwise known as FDR. So there was this magazine called the Literary Digest, and they had a huge poll. They polled 2.4 million people, and the poll showed that Landon would likely be the overwhelming winner, and FDR would only get 43% of the vote. However, the election happened and FDR won. He got 62% of the vote. So how could that happen? How could polling 2.4 million people be so far off? Well, what went wrong? The magazine surveyed its own readers, registered automobile owners, and telephone users, registered telephone users. And the problem with that is that it was not representative of America in general during that time. The people in those three groups had incomes well above the national average. So they weren't surveying, they were tending to only survey rich people during the Depression. And FDR had lots of different things to help poor people in the Depression. So it wasn't good that the bias of the sample towards rich people caused it to not be representative of America, not representative of the typical voter. And so it caused a huge problem. Okay, so large samples are preferable, but this sample was super biased. And so if you're getting a biased sample, it doesn't matter how big your sample is. So we want larger samples almost always. Larger samples are almost always better for us unless we're getting them in a biased way. And so it's something to be aware about. Okay, so the soup is not stirred very well, no matter how big your sample is. If you're like skimming it off the top, when it's not stirred well, you're still not going to be representative of the whole soup. Okay, let's do a little practice thing here. I'm going to make myself smaller so that you guys can see better. I'm not blocking out. Okay, the E is only 4. I'll be up here. All right, so a school district is considering whether it will no longer allow high school students to park at school after 2 recent accidents where students were severely injured. As a first step, they survey parents by mail, asking them whether or not the parents would object to this policy change. Of the 6,000 surveys that go out, 1,200 are returned. Of these 1,200 that are completed, 960 agree with the policy change and 240 disagree. Which of the following statements are true? Number 1, some of the mailings may have never reached the parents. Number 2, the school district has strong support from parents to move forward with the policy approval. Number 3, it is possible the majority of parents of high school students disagree with the policy change. And number 4, the survey results are unlikely to be biased because all parents were mailed a survey. Okay, so then our possible answers are only 1 is true, or 1 and 2 are true, or 1 and 3 are true, or 3 and 4 are true, or only 4 is true. So when I look at this, number 1 is possible. So which is the one that include 1? A, B, and C. Now number 2 is that it has strong support. That's with their only 1,200 of the 6,000 responding, then you can't really say you have strong support. And then number 3, it's possible that a majority of parents of high school students disagree with the policy change. I mean, it's possible. So your answer is 1 and 3. So answer C. Now, let's talk about obtaining good samples. Almost all statistical methods are based on the notion of applied randomness. Okay, so almost everything we do in this course is going to be work from applied randomness. If observational data are not collected in a random framework from the population, nothing we do in this class will work. Okay, so we're assuming randomness for all the stuff we're going to learn in this course. And so if you have a sample that's not random, then none of our tools work. Okay, so that's why it's so important to get a random sample. Okay, now there's 3 different kinds of random sampling. There's simple, stratified, and cluster. And then we're also going to talk about 2 different types of, and I'll get back to those 3. But first, I'm going to talk about the 2 types of observational studies: prospective and retrospective studies. So a prospective study identifies individuals and collects information as events unfold. So for instance, the Nurses' Health Study has been recruiting registered nurses and then collecting data from them using questionnaires since 1976. A retrospective study collects data after events have taken place. So an example might be research reviewing past events in medical records. Okay, so prospective is like, we're going to do this, we're going to start collecting data. And retrospective is like, data's been collected, let's go search through it. Okay, now let's talk about obtaining good samples. Almost all statistical methods are based on the notion of implied randomness. So I said that a couple slides ago, still worth repeating. If observational data are not collected in a random framework from a population, these statistical methods, the estimates and errors and all that, are not reliable. Okay, so the three techniques are most common are simple, stratified, and clustered. So I'm going to show you these with pictures. So a simple random sample is like, here's a bunch of things, and the red ones are the ones we're picking, picking them randomly. Okay, so that's often best if you can do it that way. Stratified sample is when you have different like groups of data. So for instance, say I wanted to know something about students at Christian colleges in Indiana. So then I could sample some students from Grace, some from Bethel, some from IWU, some from some of the other Christian colleges around the state. And they're different. So then it might be good to kind of pick the same number or like a proportional number from each college. Okay, or each stratum. Now, a cluster sample is when you have several of these different strata and you sample everything from those from a random, you randomly choose some of the groups and you sample everyone from those. Okay, and then a multi-stage sample is you randomly pick with strata and then you randomly pick elements of those strata. Okay, so this is our last practice question from this section. So a city council has requested a household survey be conducted in the suburban area of their city. The area is broken into many distinct and unique neighborhoods, some including large homes, some with only apartments. Which approach would likely be the least effective? So simple random sampling, cluster sampling, stratified sampling, blocked sampling. Okay, so the least effective is 3, 2, 1, cluster sampling, because you could end up getting too many neighborhoods with only apartments or too many neighborhoods with large homes, and then your sample would be biased. So either going with like a simple random sample or stratified sample would be better. And then blocking is something we're going to learn in the next section. So it's not even a possible really answer for this question. All right, that completes section 1.3.